answer is it's an arrow that can be used to represent certain physical quantities. Yeah, literally an arrow, like that. Well, why do we need them? Well, let me give you a counter example first, and then we'll look at some examples. What if I asked you how many are, um, how much jelly beans that you had? Yeah, a little pile of jelly beans, and maybe have some red ones, and you got some licorice, yum, licorice. You got some green ones, great, and a couple blue ones. Okay, 3. So you have your little pile of jelly beans, and I wonder how much you have. Well, you could obviously give me a number of jelly beans, or you might give me pounds, either way. But if you wanted to answer me fully, you could just say, give me a number and the units that go with it. For example, 4 pounds. That completely describes what I've asked for. So you didn't need to say, hey, it's 4 pounds west, or 4 pounds straight up, or 4 pounds in the negative x direction. You didn't need any direction to give me the information that I needed. You just needed to give me a value. Well, compare that to finding or trying to describe a force, for example. A force definitely has direction, and it turns out that force is a good example of something that's a vector. If we draw U, looking good, it really does matter the direction. For example, if I decide to be a little bit mean and come up and shove you with 500 newtons of force this way, and if that's the only if that's the force that you felt in that direction, maybe you'd accelerate in that direction. But it makes a big difference what direction we do this, because what if I drew you on top of a cliff and I decided not to push you in this direction, but decided to push you in this direction instead? So just saying that I'm pushing you with 500 newtons of force doesn't give you the complete picture. You also need to know a direction as well. Not true with your pounds of jelly beans. It is true with force. So force is an example of a quantity that's a vector, has a direction and a magnitude, a bigness. Bink, bink. So what are some other things that are vectors? By the way, things that are vectors are often called vector quantities. They have a magnitude, a bigness, and a direction. And for examples, we already know some. Force is an example. Another good example is velocity. And velocity and speed are actually kind of interesting, and you'll learn more about them if you haven't already. But velocity means not only how fast are you going, but in which direction as well. So it's a vector. Another vector example is acceleration. Another decent example is something called torque. And torque is think of it as a twisting force. If you are trying to open up your peanut butter jar of peanut butter and you provide the torque in the wrong direction, you will not be very successful. So torque has a direction as well. Another that you may have heard the word, but you might not know the real kind of physics meaning of it. But something called momentum is definitely a vector also. And there are others. Well, what if it isn't a vector? Well, it's things that aren't vectors that only have a size, a magnitude, an amount are called scalar quantities. They have a certain scale but no direction. And what are some examples of those? Well, time. If I asked how long did it take you to do your homework and you say 0.7 seconds, you didn't need to tell me 0.7 seconds northwest or 0.7 seconds straight down. Okay, you just need to give me an amount of time. Another example would be volume. Hey, what's the volume of ice cream you ate last summer? 579 cubic feet of ice cream. You didn't need to say 579 cubic feet, 35 degrees south of west. You didn't need to give a direction. Another example might be area. There's lots of other examples, but how about energy? Energy, you definitely have studied before and know a little bit about, is a really important quantity. It just doesn't happen to be a vector. It doesn't have a direction. And there are others also. So if I wanted to draw a vector, I can do that. I can actually draw a little diagram of the situation if I wanted to without being too elaborate. For example, here's you. And if I make you be running, there you go. Very serious about it. One of the things we could represent with a vector is your velocity. I could draw the tail of the vector on you, and then the head of the vector, where the arrow is pointing in the direction that you're going. And we could say, hey, your velocity is 4 meters per second. So velocity is an example of a vector quantity, and we could represent that on here. If I were to draw a pool ball, that's a pool ball, pretend it is, and I said, hey, its velocity is 5 meters per second, you really don't know which way it's going yet. So the vector itself can help you with that. So I might decide that the vector is actually this way, and the pool ball is moving in this direction at 5 meters per second. Okay. And another thing we could do is we could take you after your run up here, and you're all tired out, panting away, that's your tongue, and you're sitting here resting, cross-legged on the ground, happy to be there, all done. And we could actually draw the forces that are acting on you. And one of the forces is gravity. So again, I put the tail on you and say, okay, we've got a force of gravity acting down. And it turns out that the ground is actually pushing back up on you. If we remove the ground from underneath you, you wouldn't be being supported and you'd fall down into the hole. But the ground is there, so there's actually a force pushing up on you as well due to the ground. So just some quick examples, pretty casual examples of how we draw the force vectors, but they turn out to be very useful when you're trying to figure things out about how something is moving or what it's going to do next. There are more specific ways and more careful ways to draw vectors that are also sometimes very necessary or useful, but often drawing them as casually as we are is very useful in its own right. Thanks.